Hi, this is Miss Wiles, and this is part 2 of graphing sine and cosine functions. We left off right around here. You can either pause the video here and read the problem yourself, or listen to me as I set it up for you. There's an equation, y equals 49 plus 28 sine of pi over 6 times t minus 4. That equation models the average monthly temperature for Omaha, Nebraska. T denotes the number of months, with January represented by 1. And your job here is to compare the average monthly temperature for April and October. If you already know what to do, pause here. If you're not sure what to do, keep on listening. At this point, we'd want to understand what we're going to do by comparing. We need two quantities to be able to compare anything. So we need to find the average monthly temperature for April and the average monthly temperature for October. Nicely enough, we have an equation that models the average monthly temperature for Omaha. And all of the only variable that we have is t, and that is defined for us. So at this point, we're going to make some substitutions after we determine what t equals when it's April and what t equals when it's October. You can pause here and continue, or keep listening. Because January is 1, April will be 4, and October will be 10. Using those values, make the substitution for month 4 and find that the average monthly temperature on April is 49 degrees. And then continue for October using 10 for the variable. And this can go nicely into your calculator. And again, the average temperature is 49. And when you compare those, you say that they are, in fact, the same. Nicely done. Now we're going to talk about the graph of the function cosine x. Now, cosine is also a trigonometric function, and it is periodic because I can choose a point here in the blue, and then it comes around, it goes like this, and it comes up, and I can go here. Now, if I choose that as my starting point and my ending point, then I have to go from negative pi over 2 up to 3 pi over 2 to find my the period. And the period here again is 2 pi. Of course, I could have started at, there's nothing that says I have to start at 0, so I could have started here at the 1 and followed through and come over to the next one that I saw after the repetition or through that cycle. And from 0, the x values are where I find my domain. So from 0 to 2 pi, giving my domain, my period is 2 pi. The domain is the set of all real numbers because for every real number, there is a value for the cosine of x, of that number. The range is your y values. So range, we're looking at from positive 1 to negative 1 again. And our x-intercepts are located, the first one is here at pi over 2. This is my first x-intercept. And because of the period of 2 pi, I can find that equation. It's going to be pi over 2 plus I'm going to back up a little bit. The 2 pi, the period here, I'm going to hit a 0 more than just every 2 pi. I'm going to hit 0 here and here, or actually less. The difference between those two is only 1 pi. So every pi, every integer value of pi, or integer multiple of pi, I would say, I'm going to hit an x-intercept of 0. The first one is at pi over 2, and then plus pi times n, where n is an integer. The y-intercept is where the graph crosses the y-axis, and that is here in black as 1. The maximum values are, maximums are found on the y-axis. The maximum value is 1, and that occurs every time that we have, if you look in the black, that's going to happen every 2 pi. Every 2 pi we're going to have a value of 1, which is the maximum, and that's why it says, here's my formula, pi times n, where n is an even integer. It's going to happen on every even integer. And then the minimum value at -1 occurs when you have pi times some number where that number is an odd integer. And that's going to happen here at -1 pi, at 1 pi. It'll happen again at 3 pi and 5 pi. It'll happen at -3 pi and -5 pi. Those minimums will happen there. So you have the properties of that graph. And when you compare the two, well, let's not compare yet. Let's pause here and answer these 3 questions. In number 3, you're explaining why the cosine function is a periodic function. Refer back to the definition of a periodic function and then explain that the cosine function is also periodic because it meets those criteria. On number 6, we're looking for an actual value. What does the cosine of -pi/2 equal? And then number 9, graphing the cosine function for that given interval. Go ahead and pause here and do those 3 problems, and I'll see you back in a couple minutes. Welcome back. Let's go over these problems. In number 3, we have the cosine. Well, we could describe it, we could explain it by using this the formula. What this says is that the cosine function repeats a pattern for every 2 pi interval. And that's what you have here in this equation, that the cosine function, the cosine of some value is equal to the cosine of that same value plus 2 pi. And there should be an n here, saying that I would multiply that by multiples of 2 pi. Now, number 6, the cosine of -pi/2 is 0. And then number 9, you want to come over and block off your x-axis so that you start at -5 pi, or your graph does, up to -7 pi. Then you can find the value of cosine of 5 pi, and that's going to be -1, so you know you're here. The cosine of 7 pi is also odd, so it's going to be at -1 also. And that's a nice little pen selector that I didn't know was there. And there it is again. So we're going to get rid of that in a few minutes. Those will both be -1. So that at 6 pi, the value is going to be 1. And because of that, I know that it's just going to go up and then back down. And here on the next screen, you see, I wanted to put the properties of the sine and the cosine function on one screen so that you could compare the two. So that you could see the similarities and the differences. So let's look at the similarities, and then we'll look at those differences. We'll do some similarities in green. For both the sine and the cosine function, the period is 2 pi. For both the sine and the cosine function, the domain is the set of real numbers. For both the sine and the cosine function, the range is the set of real numbers between -1 and 1, including a -1 and 1. Then we start getting into some differences, and we will highlight those in pink. The x-intercepts of the sine function are at integer multiples of pi. So pi, 2 pi, 3 pi, 4 pi, and of course 0. and negative pi, negative 2 pi, etc. The x-intercepts of the cosine function begin at pi over 2 and then go up every integer multiple of pi. So pi over 2, 3 pi over 2, 5 pi over 2, etc. And of course negatives, negative pi over 2, negative 3 pi over 2. The y-intercept of the sine function is 0 and the y-intercept of the cosine function is 1. You can see we have some inverse things going on here. The maximum values of both are 1. In fact, of course, that is a similarity, that the maximum value is 1, the minimum value is negative 1. Those are similarities, but where they occur are different. And you can see that it's kind of flip-flopped. With the sine function, we're at x equals pi over 2 and then plus integer multiples of 2 pi. And then with the cosine, we're at x equals even integer multiples of pi for the maximum values and odd integer multiples of pi for the minimum values. And of course, all of this can be determined by graphing just a couple of repetitions of the two functions and comparing them. And I hope that's what you'll do, is look at that so that you can commit some of this to memory. We're going to look at this graph and say, okay, does this graph represent y equals sine x? Does it represent y equals cosine x, or neither? Pause here while you consider the properties of the sine and the cosine functions and whether this graph meets either one of those. And now you're back. Since the maximum value of 1 occurs when x is negative 8 pi, you notice that, and the minimum values occur at negative 9 pi and negative 7 pi. You should be considering cosine x at this point because that's when the even values and the odd values are different when we talk about those even and odd integer multiples of pi. So you should already be considering cosine, and then when you look at maybe your x-intercepts, at where you're hitting those x-intercepts on those integer pi multiples of the half, like the 3/2 pi. And so we're coming along here and those match, and so then you can determine that it is in fact a graph of part of the cosine function. Looking at number 11 here, take a look at that. Use some of the properties of the graphs to determine the answer here and why your answer is one or the other. Look at the period, look at the x-intercepts, look at the at when you hit your maximum minimum values. And so I'll let you get to that and come back into the video whenever you have an answer. You should have answered that it's neither. The period is not 2 pi. Now you have to be careful because, you know, we're going from 4 to 6 here, and so you automatically see that 2 pi, but we haven't completed the iteration that we're looking for. So the period here is actually 4 pi. It is a periodic function, but it does not represent the sine or the cosine function, not at its basic level. We'll talk about that later. It's actually kind of done something to those x values. On number 4 here, what I would like for you to do here in your notes, and I think this will help you, is to actually draw the graphs in your own hand for the sine function and the cosine function, and then compare and contrast the two. When you come back in here, what you're going to see is kind of a paragraph compare and contrast of the two, but you could certainly compare and contrast with column headings or bulleted form or whatever you feel. And once you get that done, then come back in here and see if you left anything out. And here are a couple of, oh, it doesn't want to listen to me because it knows I'm not supposed to be doing this right now. So here are the graphs. Now here they're on the same axes, but you didn't have to do that. And you can compare and contrast the two. You can compare what you have to what you see here in paragraph form. And I hope this helps you see the difference between the two and the similarities. In dit es, I'm going to try this again. In dit is all what ektese het or what. This next slide has your assignment, and I thank you for tuning in for part 2 of graphing sine and cosine functions, and I will see you in class, or not.